I would first of all like to thank Professor Amitabh Malik and the Pune International Center for inviting me to this conference to speak on the topic environmental degradation and impact of economic resilience. I intend to give here a broad overview of the ecological linkages of environmental degradation as induced by various types of human interventions and its feedback impact on the economic system in a larger perspective, in a large perspective. First of all, I begin my discussion on the topic by referring to a few illustrative extreme events in the natural and human system as recently experienced. First is COVID-19 pandemic, a zoonotic disease pandemic. Second is recent super cyclones as like Amphan in our east coast, which is unprecedented in terms of wind speed and devastation since 1737, and Nisarga on the west coast, again unprecedented since 1891. I was talking about the super cyclones. First, I talked about COVID-19 zoonotic disease pandemic. This is one extreme event. Second is the recent super cyclones, heavy rainfall and cyclone like Amphan in our east coast, which is unprecedented in terms of wind speed and devastation since 1737. And on the west coast, we had the experience of Nisarga, which was also again unprecedented since 1891. These are obvious evidences of climate change due to changes in temperature on land and sea. Then there are forest fires, which have been experienced in the recent past, say, particularly in the state of Uttarakhand. 1,000 burning sites were there in 2019, although numbers have now come down. But we have to remember that global satellite data show, in fact, that vast tracts of land in Brazil, Russia, Indonesia, and Africa have been burning for quite a number of years. And we also know about in North America how California fires are destroying the natural world there. These illustrative events are in fact the expressions of the cumulative effect of environmental degradation as exceeding some threshold levels. I'm now showing the figure which is showing the total worldwide number of all kinds of extreme events, disaster events as recorded as growing over time. From 1970, there has been a secular trend of rising these this frequency till say around 2005. Then of course there is a declining trend, but still there are fluctuations. All the countries, I now focus on this COVID-19 pandemic, which is currently we are in. All the countries, in fact, have been affected by this zoonotic disease pandemic, and the socio-economic life has been derailed from its normal course everywhere. Among the countries, in fact, India has been in the second position as in November last. The most notable feature of this disease is its very fast spread. At the start of the lockdown in India, 25th March, the total number of confirmed cases was 563, and it spiked to almost 9 million on 19 November 2020. This reveals highly infectious nature of the disease and its very fast spread caused by highly nonlinear behavior of the ecosystem and possibly the Heisenberg type uncertainty principle driving mutations and the growth of the virus or the concerned organism beyond our comprehension. We do not have possibly adequate a priori knowledge and observations, and it may be true that some of the concerned objects are not measurable due to the uncertainty principle. What is happening? I'm not being able to go to the next slide. Okay, I have. What has happened essentially is that global heating, climate change, and destruction of the natural world uh, sorry, and the natural world due to deforestation and massive change of land use have driven wildlife into the contact with humans due to their loss of habitats. Consequently, the current rate of loss of biodiversity on land in this age of Anthropocene is estimated to be 100 to 1,000 times faster than during any of the preceding geological age before the arrival of the Homo sapiens. Intergovernmental Platform of Biodiversity and Ecoservices, in its report of 2020, says that 1 million uh, animal and plant species are now threatened with extinction, many within decades, which is ever more than ever in human history. Many new zoonotic diseases like SARS, MERS, COVID-19, avian flu, swine flu, Ebola, uh, uh, Nile flu, etc., have emerged during the last 20 to 25 years. They are all linked to the transmission of microbes from animals and other life forms to human beings. I'm getting stuck every time. Sorry. This is a graph which shows, sorry, there is some problem.
Yes, sir. What is the problem?
Now it is resolved. I have to go out from that presentation mode.
All right, you can continue.
Okay. Fundamental driving factor behind all these has been the imbalance between carrying capacity of the biosphere and the human demand for its appropriation for economic activities or ecological footprint exceeding it. Ecological footprint is estimated in terms of appropriation of photosynthetic land area required to meet various kinds of human demand for its uses, like crop production, grazing of livestock, forestry, fishing, carbon absorption due to fossil fuel burning, and development of industries, infrastructure, and township. These different types of land uses are normalized for aggregation in units of equivalent cropland area of average global photosynthetic productivity. The availability of land for such uses in similar normalized unit provides the measure of biocapacity. And the excess of ecological footprint over biocapacity is called the biodeficit. Now, what is the situation for the entire world globally today? If this green line be the one as the biocapacity, then the total ecological footprint has been growing since 1961 according to this figure, the total the upper contour of this figure. Now these shades are different types of land use. Now the blue one, which is more than 50%, is really the carbon footprint, which is measured in terms of land area which is required to absorb the excess of emission over what land, vegetation, forest, and ocean can absorb. And that, if I convert in terms of additional required forest area, that is the shaded area. And that is why the carbon footprint is more than half of the total ecological footprint. And that is why climate change has become the most important factor so far as the ecological degradation is concerned. The ecological footprint exceeded, in fact, the capacity, as we noticed, around the early 70s or late 60s. We now, in 2016, we needed 1.7 unit of earth to ensure a balance between footprint and capacity. But one may question that how can the planet being a finite place, how can there be a biodeficit? How is it feasible? The biodeficit actually gets reflected in differential deficit for different types of use. And what happens is that market and state, the social preferences as reflected through the behavior of market and state, in fact, ensures a transformation of the land use, change of land use. So forest land gets converted into agricultural land, forest and agricultural land into industrial and land for industrial and infrastructural development. Similarly, similarly, water bodies, wetlands get also converted. But besides this, the overall deficit is reflected in the most important way in the deficit of photosynthetic forest area, which I called the carbon footprint. The notional measure it is a notional measure. There is no land area we can show that this is the carbon footprint. But the physical counterpart of this consequence has been the accumulation of CO2 and GHG molecules in the upper atmosphere. The environmental degradation actually started 10 to 12,000 years ago with the onset of agricultural revolution and beginning of biodiversity loss and land degradation due to overuse of land and water. So this has started, the history is about 10 to 12,000 years. In fact, there was no environmental degradation in the first 99% of human history when man was a hunter-gatherer. Now, then, when the Industrial Revolution came, based on fossil fuel, this induced really the air pollution and global warming due to particulate and CO2 emission. So the consequence has been, on the one hand, biodiversity loss due to land use change and zoonotic diseases, and secondly, the climate change due to carbon footprint. And this is leading to the cyclones, fires, and devastations. But there is a third impact which we do not see physically, but which is there. There is the social impact, a huge social impact due to disparity between the rich and the poor because of the lack of adequate rights over the natural resources by the poor. The poor get a disproportionately smaller share of benefit of biocapacity in a situation of scarcity. This results in hunger, poverty, malnutrition, disease, and premature death. This is the gap between the ecological footprint and biocapacity. Biocapacity is the green one. This is for China, and this gives how things are changing. Now, the severity of such impact of ecological imbalance on human system, however, is accentuated by the nonlinearity and complexity of the functioning of ecosystems. Most of human activities involving land use change cause fragmentation, first of all, fragmentation of ecosystems, and then biodiversity loss, and biodiversity loss reduces the resilience of the ecosystems in the event of any external shock. In the context of disease pandemic, biodiversity loss, in fact, creates niches for pathogens coming from animal bodies where they would be waiting, as if in the wings, in small numbers, to explode into large population whenever a suitable situation appears, and then creates condition for the new pathogens to evolve through mutations as part of nonlinear regeneration process. The very frequent mutations of the strains of COVID virus, like UK strain, as people are suffering in various countries, are the examples of such situation, which has been very challenging for our virologists and epidemiologists. But finally, the impact of global warming through nonlinear process on climate change is becoming so serious that the next ice age is going to be postponed by 50,000 years, according to the Potsdam Institute of Climate Assessment. This just indicates, signals the seriousness of the matter.
I'm sorry, sir, to come in, but your time is up. So could you please conclude your session?
Well, I lost some time. I'm sorry, because of it got repeatedly stuck.
Sure, sir.
Also, I had to repeat certain things because I could not feel that well. You are not being able to see. So please,
sure,
you have to allow me to finish.
Sure,
There are a couple of more slides. That's all.
All right, sir.
Now, what should be the policy approach? The policy approach has to be that we have to be operating, economies have to be operating within the safe operating limit of world's ecosystems. That is zero ecological imbalance. Now, but the point is this, given the growth rate of global GDP per capita at the rate of 3.4% per annum and the rate of decline of global natural capital stock at the rate of 0.3% per annum, as experienced during the periods in 1992 to 2014, such attainment of goal in the time frame of 2030, say, would require the global productivity of bioresources in terms of GDP to grow at the rate of 9.1% per annum. This is going to be too tall an order in view of the fact that the global productivity of bioresource has been increasing at the rate of 2.5% per annum over time. Now, if the productivity of natural resources cannot grow at such high rate, then what is the way out? The only way out is that we have to reduce the growth of both population and that of per capita income. But how can that be feasible? The reduction of growth rate requires a change in the preference structure of the society, a redistribution of income and wealth, and our ethical and value system. This would require change in mindset and our ways of thought, our long-run policies for development of technology and resource use to optimize growth and redistribute the benefit of use of global biocapacity among the global rich and the poor. Finally, our policy initiatives and actions need to be combined with our genuine political will, which we are often lacking, in fact, and with our intellectual and emotional commitment to humanity for the universal and equitable sharing of rights to global resources for the development of all. Thank you very much.